I was under the impression that I was cleverer than others, the world. Um, and I suppose, depending on how you measure that, that might be true in some cases. But I think the thing that I got, maybe the best thing that I got from any cleverness that I do, did, or thought I had or have, is realizing that it's not a good position to be in to think one is too clever. Um, and I I think I've made a lot of strides, it being 2020 and um, having spent a chunk of time unemployed, about to have my third or fourth move in the last 6 months, um, because I did land a job, but I've learned not to really be able to unclench about that until I get my first paycheck. So moving towards a job in a couple days. But point being, I've hit a point where I don't think I can out clever whatever comes my way anymore, and whew, I am very happy about that. There's a trying times do really present a opportunity for personal growth in many cases, or at least in this case. I don't think I can make it a general thing, but there's some wisdom to that. Some truth to that common sense wisdom, or that I don't know how to categorize it. Um, yeah, so uh, yeah, it's just a thing that I'm trying to be grateful for. It's a hard lesson to learn. Um, I what was I gonna what was I planning on saying? I was planning on talking about something. Oh yeah, first of all, what you're looking at is the Potomac um, in Alexandria, Virginia, as it pans to the well. You might not be looking at the screen. You might be looking at the stars or a dog in your life. I don't know. Um, but what the visual that comes with the audio that I'm recording here is of the Potomac. So yeah, uh, that's now looking north. If you could see past that dilapidated little whatnot, that's Washington D.C. over there. So what I was planning on talking about is math as art. Because math is a great tool. I think we can all kind of agree on that. It has a lot of useful properties. It can do some nifty tricks. But a lot of the great makers of math in history, first of all, a lot of times back in the day, they were usually theologians of some sort. That the divinity was seen in math and logic, truth seeking, all that jazz. Um, and as time has gone on, it's become secularized, and logic spawned math because logic is, philosophy is a big bubble, and on the edge of that bubble, there's a bubble that is logic, and on the edge of that bubble, there is logic as applied to numbers, which is math. But there are also like discrete math is math that doesn't necessarily use numbers. So I would argue that it's actually logic, not math, but it's in the field of math because it's a whole to do. Gotta say. But a lot of mathematicians today and in the past, the beauty of it, the elegance of it, the finding making interesting puzzles and then solving them, or that that is what actually has driven a lot of the development of mathematics in history and today. And I think that really enamors me. The it's a great example of something that has both form and function, um, and I guess you could interpret form multiple ways because boy howdy does it have form. Um, yeah, I think one of the greatest things uh, is in best shown in computation, as like computers, like machines, Turing machines, even abstract machines that you don't have to build. You can, just agree with somebody. Okay, if there's this rule for this machine and there's this rule for this machine, then it will operate on input in this way. And I love that it's something that can come with its own context. And in language and in, well, informal language, in conversation and in art and memes, whatever your messages you're sharing, interpretation is often very subject to interpretation of who's looking at it. Where I feel like computation, the algorithms of, hey, let's make a hypothetical or real machine that acts on input in these certain ways, and then we can both look at it and work out how it would react to certain input. And that message plus reader of message being part of the external world that we can talk about, I think does a world of good for communication, because a lot of it it helps avoid problems of defining terms. When I say this, I mean this. When you say this, when I say X being a word, I might assign it a certain meaning, but words often are, homonyms or eponyms or whatever, where the same word can have multiple meanings. Goat is an animal, but it's also, you can get somebody's goat. It's a phrase. That's maybe a terrible example. Let's say, how about just a distinction of noun versus verb? Bubble, since we're looking at water. Well, since I'm looking at water. A bubble is you can have a bubble, but something can also bubble, do bubbling. If I go underwater and breathe out, I make bubbles, and so I bubble, but I guess I was going to say, I guess arguably I could be considered a bubble because I'm, covered in skin and practicing homeostasis, so I'm just a person-shaped bubble. Well, human-shaped bubble. I don't know what a person-shaped bubble shape is. Um, uh, yeah, you need a lot of context to know what I mean when I just use the word bubble, because it can have, I could also mean like a bubble, like a social bubble, like a clique, or a thousand metaphorical meanings I could be assigning to it. And as much as we want people to just understand what we mean, it's it's hard. And computation, the building of abstract systems for taking in data and acting on it, that extra level helps bridge communication because I'm not trying to explain what it's like for me to experience something. We're both building a thing that we're modeling in our head or empathizing with. I guess I think of it as empathizing with a mechanical system, but I don't think that's a general. Here we go. If I look at a non-human thing, and I say, what is it like to empathize with a fish or a tree or water or maybe I mean, and I might mean, I personally do mean, like a physicist would be if I'm crunching the numbers for how a rock falls on the Earth, gravity, force, or rate of acceleration rather. Force of gravity, yeah, well, it is a force. It's curvature of space. It's all. I'm not a physicist. It's very confusing. But the if I'm crunching those numbers, if I'm looking at the equations, if I'm figuring it out how it works, and I develop an intuition for how it works, where I can crunch the numbers, but like I have a ballpark of what the number. I've done this enough times. I can kind of guess where it's headed, and I might be right or wrong, but I feel like, in a way, well, when I use the term, I'm empathizing with the system of gravity and the stone. And so there is that possibility of empathizing with an inanimate object because, well, math lets me do that. Or let's say skipping a stone. I did a lot of that in my childhood, throwing a rock at a certain spin at a certain angle on the water to try and make it skip as many times as possible. I'm extending my understanding to try and figure out how, or maybe not even figure out intellectually, but getting a feel for, because I wasn't crunching numbers when I was doing that. It was fun. It was just a thing to do. But the more I did it, the better I got at it because I had models in my head of how it works. And they may not have been mathematical, or at least not explicitly mathematical, that I was aware of. But the more I became familiar with and understood how changes and how I held the rock and how I threw it and what kind of rock I was using and how calm or bumpy, wavy the water was, choppy, how those might affect, how I might adjust what I do to optimize the number of bounces for the given conditions. And I'd experiment with little rocks, big rocks, rocks of sizes or shapes that I wouldn't expect to skip just to see if I could. And so overall, I feel like I I don't think it's unreasonable to say that there's an empathy there for the stone or the water, or at least me looking back on it, I empathize with myself engaging with those things. So that's a form of empathy, even if it's just for past versions of myself. Yeah, and now where was I? Did I have a point? I don't know that I had a particular point other than it's neat to look at math as art. Yeah. And yeah, I think I think the fact that we teach math only as a tool generally and not as a, hey, it lets you empathize with inanimate systems. Isn't that neat? Or animate system. It, teaching it as a tool of, hey, it helps you understand a thing. Or, as I'm kind of recharacterizing the word, empathizing with it. Um, or, hey, just there's some pretty stuff we can make out of math that you can or maybe not even pretty, but beauty. The difference between beauty and pretty, that's hard. Anyway, um, even things like trying to think of shapes in 4 or 5 dimensions, like I mean, it's just cool. It's neat. It's a weird feeling. And the video is coming to an end. So enjoy.